Good day wherever you are viewing us from, and you are welcome to MLT channels in the mega city of Ibadan. Today's subject matter is chemistry, and the topic of discussion is matter. You are welcome on board. As usual, the first task in the class is to highlight the performance objective of today's class. At the end of lesson, learners should be able to describe matter, state the particulate nature of matter, and describe the state in which matter exists in terms of kinetic theory of matter. That having been said, now let's move directly into the subject matter. So, as usual, we always start with one more question to serve as the entry behavior or the previous knowledge of the class. So under the warm-up question, we have question 1, what is matter itself? 2, what is matter made up of? 3, distinguish between physical change and chemical change. 4, define pure substance. And the last but not the least, give examples of impure substance. By the end of class, solution to all these warm-up questions should be easier for learners to state or describe. Alright, let's now move to the topic in details. And the first task is, what is matter? Okay, simply, and as we all know, matter is actually everything around us, either seen or unseen. But scientists put it as matter is anything that has mass and occupies space. It is actually made up of small particles known as atoms, molecules, and ions. And the state in which matter exists are represented in the diagram below. Matter actually exists in 3 states: in solid state, in liquid state, and in gaseous state. So in summary, on this slide, we'll be able to define matter as anything that has mass and occupies space. We have also made mention of the particles that matter is made up of, which are the atoms, molecules, and ions, as well as the state in which matter exists, which are the solid state, the liquid state, and the gaseous state. With this, the first objective of the class has already been achieved, which is, at the end of the class, learners should describe the meaning of matter. Alright, let's move on. So moving on to the next slide now, we have particulate nature of matter, which actually represents what matter is made up of. As we have stated earlier, matter is made up of atoms and ions. Now, we need to describe what these are. And the first one to look at is atom. Well, atom is actually the smallest particle of an element which can never exist alone, but it can take part. The word atom was first coined by the scientist known as Democritus. That was the first scientist that coined the word atom. And although he didn't really give us much details about what atom is, but credit was given to him as the first man to use the word. Details about what atom is was actually given by John Dalton in his postulate in 1803. So, under the Dalton's postulate, Dalton let us know that atom is the smallest indivisible or indestructible particle. Yes, he said matters are made up of smallest indivisible or indestructible particle known as atom, which buttresses what I've said earlier, that Dalton described atom as indivisible and indestructible particle. He also further said that atoms can neither be created nor destroyed. Then thirdly, said atoms of the same element are alike and they differ from atoms of other elements. And he also said that atoms combine in volume, we do so in simple ratio. And finally, he said all chemical reactions are a result of atomic combination or separation. Well, we believe all what that is said for about 101 years until scientists like J.J. Thomson and Lord Rutherford let us know that atom that Dalton claims is the indivisible is actually broken down into subparticles which are the proton, neutron, and electron. So almost all Dalton's atomic theory were modified, except the last theory which says that all chemical reactions are a result of atomic combination or separation. Almost all were modified. He said atom can neither be created nor destroyed, and during nuclear fission, uranium-235 is actually destroyed to form barium and krypton. He also said that atoms of the same element are alike and differs from atoms of other elements, which is untrue, because isotopes let us know that atoms of the same element may not also be completely alike. Then he said atoms combine in large in simple ratio, and even large molecules like protein and carbohydrate, they combine in large ratio. So almost all Dalton's atomic theory were modified, but that is not the scope of this class. That will be in the later class when we are talking about atomic models, where we are going to look at John Dalton's model, Ernest Lord Rutherford's model, J.J. Thomson's model, as well as Niels Bohr model, as well as Edwin Schrödinger model. But the aim of this class is just to give a brief about what atom is, which we have defined that is the smallest particle of an element which can never exist alone. Atom can never exist alone, but despite it can take part in a chemical reaction. That's the first thing matter is made up of. Then the second thing is the molecule. When atoms combine, a molecule is formed. Let's take for instance two atoms of oxygen. They combine to give a molecule of oxygen, which is O2. So when atoms combine, a molecule is formed, and scientists define molecule as the smallest particle of a substance which can exist on its own. That's one of the difference between atoms and molecules. Molecules can exist on their own, while atoms can never exist on their own. An example of molecules are H2, that is hydrogen molecule, O3, that is ozone molecule, S8, that's also sulfur molecule, and so on. Then the last thing that matter is made up of is ion. And when we say ion, we are talking about charged particles. Ion is actually an atom, or it will be a group of atoms that possess an electric charge. An example, we have H plus. That is when an ion is existing as an atom. We have O2 minus. It's also existing as an atom here. Al3 plus also existing as an atom here. Y3 minus here is existing as a group of atoms, which is also known as radicals. So on this slide, we have been able to look at the particulate nature of matter, which are atoms, molecules, and ions. And these are the three particles which matter are made up of. And we have defined atom as the smallest particle of an element which can never exist alone but can take part in a chemical reaction. We have also defined molecules as the smallest particle of a substance which can exist on its own. Ions are atoms, group of atoms that possess an electric charge. Alright, with this, let's now move to the next slide. Now on this slide, we have a class drill to assess what we have learned so far in the first two slides. And in question 1, define the following terms. 1. Atom. 2. Molecule. And 3. Ion. If you have mastered what we did in the previous slide, you should be able to define these three particulate nature of matter. Then question 2. How many atoms are there in one molecule of water? That's a very brilliant question. one molecule of water is represented by H2O. So how many atoms are here? That's a big question for you. Then question 3. Distinguish between an anion and cation. Given two examples for each. Yes, good. That's another good question. We have discussed about what ion is. An ion is divided into two, which is anion and cation. And we've even cited example of some of them. We've cited some example in the previous slide that are a cation, and we have some of the example that are also an ion. So also try and lay your hand on that. Then the final question on the class drill is, what is room temperature? And this particular question will go a long way in assisting us in the next couple of slides. All right, let's proceed. Now, and also the second aim of the class has already also been achieved, which is particulate nature of matter. Don't forget, we said that at the end of class, learners should be able to describe the particulate nature of matter. So now let's move to the last segment of today's class, which is state of matter. So under the state of matter, actually matter exists in three states, which are solid, liquid, and gas. We'll now look at these three states of matter in terms of kinetic or molecular theory of matter in the next couple of slides. On to the next slide now, we have solid. And when we say solid, what is solid? Actually, for us to be able to know that a substance is solid or liquid or gas, the benchmark is the room temperature. It's the room temperature that determines the state in which a substance exists. And what is room temperature? That was asked in the class. Actually, room temperature is the ambient temperature of the environment, whose value range between 20 to 25 degrees Celsius. And that determines the state in which matter exists. So when we say it's solid, as you can see in this diagram, a solid, which is ice. Although it is ambiguity to call ice a solid. Ice is rather a liquid, but just existing in solid state. And this will take us to the definition of what solid are. Actually, solid is a substance that melts above room temperature. I repeat, solid is a substance that melts above room temperature. And what is the value of room temperature? Temperature is actually 20 degrees Celsius. That implies that any substance that doesn't melt at this temperature is solid. And that now brought about the argument I made earlier that ice will just look like a solid, but ice is not really a solid. It is actually a liquid that is existing as a solid, that exists in a solid state. Okay, why do I say that? Because ice will remain ice when it's inside the refrigerator, where the temperature is less than 0 degrees Celsius. The moment you remove ice and you place it in room temperature, which is 20 degrees Celsius, it's going to melt and turn to liquid. So invariably, that is letting us know that ice is not actually a solid. It is rather a liquid that is in solid state under a certain condition when it's below 0 degrees Celsius. Now, having defined what solid is, what are now the properties of solid? 1. Solid have a definite volume and shape. As we can see in this ice, all these ice, they are cubic in shape. So solid have a definite volume and shapes. Then the molecules of solid are closely packed because they are held together by a very strong intermolecular force. Here is the molecule of solid. We can see them now. And we can hardly see any space between them. They are closely packed. And why are they closely packed? Because they are joined, the molecules are joined or held together by a very strong intermolecular force. In order to explain how close the molecule of solid are, I used to use this as an illustration. No substance can dive directly or penetrate directly into solid without breaking. It is impossible. Let's take for instance, we have seen in American film in which actors are diving from aeroplane or helicopter into the air. Because why? The molecules of air are widely apart. And we've also seen in movies where actors are diving into liquid. Why? Because the molecule of liquid are loosely packed. But never will anybody or any object dive into a solid. If object dive into a solid, such object will break. Why? Because the molecules of solid are closely packed. And the reason why they are closely packed is because they are joined by a very strong intermolecular force. Then the state of this molecule, the molecules of solid doesn't move, but they rather vibrate about their mean position. Then solid are incompressible. You can't compress solid, and they cannot even flow. These are the properties of solid in terms of molecular theory of matter. Now, before we move away from this slide, we have looked at what solid is, and we said solid is actually a substance that melts above room temperature. Then the properties of solid. Solid have a definite volume and shape. Then the molecules of solid are closely packed because they are joined together by a very strong intermolecular force. The molecules of solid do not move. They rather vibrate about their main position. Solid are incompressible and solid cannot flow. I hope this is explanatory enough. If then, let's move to the next slide where we'll be looking at liquid. Now, liquid. What are liquid? Actually, liquid are substances that boil above room temperature. Don't forget that in the previous slide, we said that room temperature is 20 degrees Celsius. Let's take the commonest liquid as a case study, water. The boiling point of water is actually 100 degrees Celsius, and that makes water a liquid because it boils above room temperature, which is 20 degrees Celsius. Now, what are the properties of water? Water takes the shape of the container in which it is entrapped. Yes, water do not have a definite shape. Although they have a definite volume, but they didn't have a definite shape. They rather take the shape of the container they are entrapped in. Let's take for instance, in this diagram, we have a glass cup, which is cylindrical in shape. If you should pour water inside it, the water will take a cylindrical shape, telling you that water takes the shape of the container in which they are stored. Then what is happening to the molecules of liquid? Do I say water? I'm supposed to say liquid rather. The molecules of liquid are loosely packed. Yes, compare them with that of solid. You can see that this of solid is closely packed. So that of liquid, look at it there. This of liquid is loosely packed. Why are they loosely packed? Because they are held by a weak intermolecular force. That is why when you are looking at liquid from above, you didn't see any space. But when you drop a particle like a stone inside, it's going to percolate and move down to the bottom of the liquid because the molecule of liquid are loosely packed. Then what's happening to the molecule? What's the state of the molecules? The molecule of liquid always slide over one another. You can see a water producing ripple or a water wave when a stone is dropped into it. That's how the molecule of liquid moves. They slide over one another. Then liquid can be compressed but not easily. Unlike solid that cannot be compressed at all, then liquid can flow. Alright, on this slide, we have looked at what liquid is in terms of molecular theory of matter, and we have defined liquid as substance that boil above room temperature. Then what are the properties of liquid? Liquid have a definite volume, but take the shape of the container in which they are entrapped. Then also, the molecules of liquid are loosely packed because they are held together by weak intermolecular force. The molecule of liquid slide over one another, then liquid cannot be easily compressed and liquid can flow. Now on to the next slide, which is gas. What is gas? Actually, a gas is a substance that boil below room temperature. Yes, gas boil below room temperature. And unlike liquid and solid, gas do not have shape or volume. They didn't have shape and they didn't even have any volume. Then the molecules of gas are wide apart because they are held together by very weak intermolecular force. That is why you can see substance penetrating and flying easily in the air. Why? Because the molecules of gas are loosely packed. Then gas can be easily compressed and gas can flow. All right. That will be all for today's class. And don't forget, when we started the class, we said that the aim of the class are: 1. By the end of lesson, learners should be able to describe the meaning of matter, which we have dwelt so much on. Then 2, learners should be able to describe the particulate nature of matter, the particles that matter is made up of. We have also discussed about that, and the state in which matter exists in terms of kinetic theory of matter. Alright, if this is clear enough, now let's now assess ourselves with the class view to evaluate what we have learned so far. And we have a revision exercise. Question 1. In a tabular form, compare and contrast the property of solid, liquid, and gas in terms of molecular theory of matter. If you have been very focused and follow what you have been doing so far in the class, you should be able to answer question 1 correctly. Then question 2. State 5 postulates of the kinetic theory of matter. Yes, this was not captured during the lesson, but you can search this online or consult your textbook in order to know about the kinetic theory of matter. Then the final question is: distinguish between real gases and ideal gases. All right, 23 minutes just gone down like 23 seconds. At MLT, we are determined and dedicated to achieving the excellence in all our endeavors, and we are proud to have assisted numerous students to achieve their grades and secure admission into their most preferred university. To register with us, you can come to our tutorial center at Omega Building, opposite Gasland Station, Obafemi Awolowo Way, Malete, Ibadan, or join our online or virtual classes just with a single call or chat. Call or chat Engineer Ladipo on 080-670-76871 to join our virtual or online class, and you start preparing for your WAEC, your NECO, and your UTME that are around the corner. We also use admission process for candidates seeking admission into tertiary institution. At MLT, we are your road into your dream university. Okay, you can view all our videos on our YouTube channel, and our handle is at Oladipo2262. Don't forget to subscribe and assist us by sharing our video wide and far. Thank you very much for your time. Until we meet again, I remain my humble self, Engineer Oladipo Nurudeen, your host